This is Lecture 8, Calculating Estimates, Graphing Estimates, and Interpreting Estimates. By the end of this lecture, you should be able to know how to calculate and interpret estimates when focusing on dummy variables, and know how to calculate and graph estimates in SPSS when focusing on continuous variables. At this point in the semester, you should have a good idea as to why we use regression analysis. We have a dependent variable, and independent variables we think influence our dependent variable. Regression analysis allows us to determine if our independent variables actually do have a statistically significant impact on our dependent variables. At this point, you should know how to interpret a regression analysis in SPSS. If not, go back and rewatch Lecture 7. In this lecture, I'm going to review how to make multivariate regression estimates and interpret them. I will go through the process more slowly and in more detail, as you will have to know how to do this for your final research paper. Consider the following hypotheses. On average, democracies have a higher GDP per capita than dictatorships. As ethnic fractionalization increases, GDP per capita decreases. In order to assess whether these hypotheses are supported by the data, I ran the following model in SPSS. GDP per capita is the dependent variable. It can only take on any positive value. Democratic regime is the first independent variable. It is a dummy variable. It takes a value of 0 for non-democracies and a value of 1 for democracies. I expect this variable to have a positive impact on GDP per capita. Ethnic fractionalization can take on any value between 0 and 1, with higher values indicating that a country is more fractionalized. I expect this variable to have a negative effect on GDP per capita. Here are the results of the analysis. The coefficient for democracy is positive, which is what I expected. It is also significant at the 0.05 level. Since this is a dummy variable, because it only takes on values of 0 and 1, I conclude that, all else equal, GDP per capita is 5,828.473 higher in democracies than non-democracies. The coefficient for ethnic fractionalization is negative, which is what I expected. And it is significant at the 0.02 level. Since it is a continuous variable, which means it can take on multiple values, I can conclude that, all else equal, as ethnic fractionalization increases, GDP per capita decreases by 14275.387. Now on to making estimates. The first step is writing out the regression equation. Next, you work on making estimates for each variable separately. So starting with the first variable, if the coefficient for the variable is not significant, you move on to the next variable if there is one. If the coefficient is significant, then you can make estimates. If the variable is a dummy variable, you make two estimates, one for each category of the dummy variable. Then you interpret these estimates. If the variable is continuous, you make estimates across all the values of the independent variable and graph the estimates against the independent variable. Then you interpret the graph. So now I'm going to go through this process with the regression I ran earlier in the lecture. The first step is writing out the equation. Based on our regression results, we have GDP per capita hat equals 5828.473 times democracy minus 14275.387 times ethnic fractionalization plus 16755.304. Our first variable was democracy, and it was significant, so we can make estimates. The variable was a dummy variable. So now I will talk about making estimates for dummy variables. Remember, with dummy variables, we only make two estimates, one for each category of the dummy variable, 0 and 1. So to do this, we start with the equation here, and we will vary democracy and set ethnic fractionalization constant at a certain value. Note that if there were additional independent variables in this model, we would also set them equal to a constant value as well. So what should we set ethnic fractionalization equal to? It could be the minimum value, maximum value, or the average value of ethnic fractionalization. To find the minimum, maximum, or average value for ethnic fractionalization in SPSS, you can run descriptive statistics in SPSS. In SPSS, click Analyze Descriptive Statistics Descriptives. You place your variables in the variable box. In this case, I would have put ethnic fractionalization in this box, and then click OK. So I'm going to set ethnic fractionalization constant at its average, which was 0.05. So I rewrite my equation, replacing ethnic fractionalization with 0.05. Next, I write two new equations, one where I replace democracy with a 0 and one where I replace democracy with a 1. So for the first equation, we get 5828.473 times 0 minus 14275.387 times 0.05 plus 16755.304, which equals 16041.53. For the second equation, we get 5828.473 times 1 minus 14275.387 times 0.05 plus 16755.304. The next step is to interpret these values. The first equation tells me the average GDP per capita of non-democratic countries with an average ethnic fractionalization. So I can say non-democratic countries with average ethnic fractionalization should have 16041.53 GDP per capita on average. The second equation tells me the average GDP per capita of democratic countries with average ethnic fractionalization. So I can say democratic countries with an average ethnic fractionalization should have 21870.01 GDP per capita on average. When interpreting your estimates, make sure to indicate what values you set all the other independent variables to. Now that we're done making estimates for the first independent variable, we can move on to the second independent variable. Our second independent variable was ethnic fractionalization. It was significant, so we can make estimates for it. And it is continuous. So we would calculate estimates for that variable and graph them in SPSS. So to do this, we start with this equation here. And we will vary ethnic fractionalization and set democracy equal to a constant value. Note that if there were additional independent variables in this model, we would set them equal to a constant value as well. We could use descriptive statistics in SPSS to find the minimum, maximum, and average of democracy, but since we know it's a dummy variable, it's probably best just to set it equal to 0 or 1. I will set it equal to 1 just for demonstration purposes. So here's the equation I get. Now it's time to enter this equation into SPSS. You click Transform, Compute. You put your equation in the numeric expression box. Note that you should have no spaces in this equation. In addition, this equation must have the exact variable names SPSS uses. You can click the variables over into this box here. So my equation should be 5828.473 times 1 minus 14275.387 times eth frac plus 16755.304. In the target variable box, put the term estimates. However, if you already made an estimate for another variable previous to this, type in estimate 2 or estimate 3. If you do not follow these rules, SPSS will not be able to make the estimates for you. And then you would click OK. Now it's time to graph the estimates. Click Graphs, Legacy Dialogues, Scatter Dot, choose Simple Scatter, and then you will put the estimate variable in the y-axis box, put the independent variable you varied in the x-axis box, in this case it would be eth frac, and then click OK. And once SPSS creates your graph for you, you can copy and paste it right into a Word file. The last step is interpreting the graph. You should describe the general effect of the independent variable on the dependent variable in the graph. Make sure to indicate what values the other variables are being held at in your interpretation.